putting through. You take the insulation off the cable, clamp it in there with some conductive grease, and then seal it all up. And it forms a ground connection to the tower at that point from all of your shields of your coaxes. On the other side of this, there's also two more blocks where two pieces of heliax come through, which I think I've got a photograph. You'll see that in a little bit. That being said, this is made out of aluminum. Let's talk just a moment about metals, because conductors, the type of conductors that you use in this is rather important too, for a couple of reasons. Number one is the conductivity of the particular conductor. Of course, we all know copper is a good conductor. Silver's great, but it's a little expensive to be hanging around on all your stuff. Aluminum will work, but there's a downside to aluminum. And then you've got other metals, steel and stainless steel and so forth, and a lot of those are a little farther down the ladder. But another reason you have to pay attention to your conductors is because of the fact that a lot of metals aren't compatible with each other. If you've ever run into the galvanic action of two metals together that were on the wrong ends of the nobility chart, you'll know what I'm talking about, because sometimes that's an unintended consequence, and other times it's something that you want to do. Let's see, there's my noble metal chart. I would imagine that probably at least one of you in here has got a boat, and somewhere on the motor is a piece of a magnesium on there that is supposed to go away to keep your nice propeller from not going away, or keep the bottom end of the motor from going away. It's sacrificial anode, and you'll find sacrificial anodes made out of aluminum and magnesium, occasionally out of zinc. That's what they're for. They do that, but that's the reason why you don't want to use those kind of metals with a more noble metal like, say, copper or tin, because your aluminum or your magnesium will start to disappear on you. And so you have to be careful if you use those kind of metals, that you either put some type of a buffer between them to keep from a bridge forming across that joint. And a lot of people, what they'll use is a little bit of stainless steel. Or you can use a compound. I brought some of the compounds that I've used with me here. This is a grease that's got loads of copper in it. It's called jet lube. This is stuff that electricians use, Penetrox. It has zinc in it. Here's another one called Noalox. It's real similar to Penetrox. Electricians use that. Now here's some stuff that's kind of interesting to use. This is just a dielectric grease. You can buy this at any auto supply store. What it's for is for keeping your taillight bulb from corroding and stuff like that. You smear a little bit on it when you plug it in. What happens is the two pieces of metal kind of rub through the silicone. It makes good contact, but this protects all the exposed areas so water doesn't get to it. It's real good to use, although it's not conductive by itself, but it usually will move out of the way, and it keeps water from bridging that gap. And usually it's moisture that lets those ions pass between a noble metal and a less noble metal, and it starts the erosion process. So generally you want to goo up a connection with something like that, either to cut down on that galvanic action, or so that you have better conductivity. Now this copper stuff, that's what it's really good at, is it gives you conductivity.